Okay, so let's get myself on the screen here. What I wanted to do today was had sort of a fun idea planned where, well, let's wait. Honestly, I need to remember to stop this. There we go. So the idea was that we would not have this problem where we're not compiling at this point. The idea for this stream was to have like an AI guy just walk wherever I click, basically. But in order for that to happen, setting up for today, I was sort of rushing through a big refactor of some of the physics stuff, and it's definitely not done. So I'm going to try to hack to get to the physics really quick, and then get to that point where I can just, click to a point and watch like a little AI guy move to that point. The idea being there that that's like the first step to just having AI guys move anywhere. Okay, so I need to fix this problem. Let's do that. Let's see. Physics update. I need to not have totally incomplete code. That's probably the first step. Evaluate. Okay, cool. So this is the guy. He is I guess technically an AI guy, barely. If I select him and I give him some linear velocity, I'm actually not sure what's gonna happen. Oh, he moves. Look at that. Oh, hey, look at him go. I actually didn't think it was gonna work. I was like furiously typing, getting the physics to a good spot for about an hour straight, and I'm shocked he actually moves and doesn't look super janky. I just want to see that again. Hold on. That's kind of a nice payoff. Yeah. Oh wait, slow down, buddy. Slow down. No, it's going way too fast. Oh, he can walk backwards. Of course he can. All right, cool. Cool. All right, so I want to get this guy to basically I want to select him, and then I want to like click over here and have him move toward the point. He's not gonna have any pathfinding or anything. He's just gonna move straight to the point. Is the idea. Okay. Well, shoot. Yeah. Now that he can move, now that I know that moving works, I'm gonna turn this music for myself a little bit. That's a little bit loud. Okay. Yeah, now that he can move, I'm not going to worry about friction. Yeah, I'll do that. I'll do that at a different time. We just want to first, I guess, be able to click on the origin plane, so on the plane that literally everything is on right now. And I guess that's the first thing. So what am I going to do? I guess maybe hack that in, or... Yeah, okay. Let's look at our input bindings. Let's see. No place. So if we go to input binding procedures, whenever I click right now, it calls respond to left mouse button click. That's what's bound to it. What I'd like to do is maybe check that if I'm in like a, little hacky debug mode just for this session. So I'm gonna make a global for that for simplicity's sake. Right? So, and this is like the input section here. So. Stream click mode. There's the bool, and we're just going to say it's true by default here. And I'm going to want to be able to turn it off. So when I click, I want to be able to get the guy to move there, but I also want to be able to select entities as I can now. So I need to be able to turn it off as well. Maybe, you know what? Let's make it a right click. I don't even need a setting for that. that. So we're going to make a new input binding procedure first to do that. So this is going to be just respond to RMB click. It's going to do a lot of the same things. Let's see, dev GUI, use a mouse cursor. Yeah, this essentially has like almost exactly the same beginnings, except that I don't need it to be, so I don't need any of that below that part. I'm just going to do array cast to a plane. So let's open up physics, and we can actually use raycast simple. Why not? I'll do it that way. So result is a raycast simple, and I'm going to raycast plane to result. Origin is going to be the camera location, so that is free fly camera position. The ray direction is oh wait, I have this right there already. Ray origin, ray direction. Actually, yeah, that's right. If the camera's orthographic, the origin isn't actually the position of the camera. It's potentially offset left or right, because the ray actually goes through the screen rather than originating from some point behind the view. But it's perspective, so it would work either way, but I can go and use these computed values here. Okay. When on plane, that's going to be the origin there. This just defaults to 0, 0, 0. That's all that does there. And then the plane normal is z equals 1, right? And z up. And so if that's a hit, then I want to draw a sphere there to denote that we've hit the plane. So draw a sphere with the, let's use, always using context.world, always in the world. Alright, so we're drawing a sphere with the render. The sphere is at result.hit location, and I honestly don't remember, so I have to look up draw sphere because I don't remember it. Disadvantages of not using a language server, but okay. The code's simple enough that it never really matters. Alright. So the radius, I don't know, 0.2 is probably fine. Let's try 0.3, kind of big. I'm gonna make it red, so it's really visible. Line width 2 maybe, segment count 12 is fine, and the time, let's say you see it for like 5 seconds or something. Okay. So wherever I click, not render. Okay. Wherever I do a right, oh, it's right. No, I made the procedure, but I need to bind it first. So respond to RMB click. Gotta bind it. So an input in response right here. So we're going to make an input binding. Just copy this one. And respond to RMB click, and it's mouse button right. Okay. Works in both modes, that's fine. Okay. Cool, so now I can still select the guy, and it's not working. Oh, you know what? I am already using right mouse button for free fly. I don't have modifiers yet, so I can't do I can't be like control right click. Could add that, but that would be maybe not the most interesting thing. So I will just map it to a different key. And I don't know what P. Here, P for point. Respond to P. No better name. Okay, respond to P. So wherever my cursor is pointing when I press the P button, it's not going to work. Shocking. I guess I'll step through it. That's annoying. Okay, input binding procedures. I want to respond to P. Just press P. Okay. Let's see. I think I messed this up. I think it should be negative plane normal, if I'm not mistaken. Right there. I think that's right. And still not working. Cool. Well, that's done. Good on this. All right. All right. So pointing cosine t is positive. Hit distance result still negative. Oh, wait, how does that make sense? Plane normal. Z obviously pointing cosine t positive. Pointing cosine t. Pointing cosine t should be negative, and sine distance plane should be negative. So this one. Did I do it? Wait, that wouldn't make sense either, would it? Just a plane, that would be negative. Oh, there it is. It's really just only not. Wait a second. Not drawing for that amount of time. There we go. Ugh. That all worked out for nothing. Okay. So yeah, I can point to the origin plane, and I want to say have this guy move in this direction, right? Pretty basic idea. Pretty basic. Let's let's do that with physics. Okay. So I have an intelligence update already and blank. And if I say, maybe let's go back to globals and make that that position that I'm setting a global position that I can always reference. Okay. So stream AI go to position. Okay. And then in intelligence, we can always reference this and accelerate toward it. Alright, so difference is going to be the AI go-to position minus this. So physics, alright, you can get the I really should make like a for loop. You know what, maybe I'll do that right now. I want a for loop where I have the component and the entity reference along with it. Basically the way this component system works is for any component that an entity might have, there's two parallel arrays created for it. One array of components and then one array of IDs to back reference who owns the component. But if you just iterate over the components, you're not iterating over the IDs. It's really easy to just be like, okay, intelligence is IDs, ID index. But this would actually be a nice point to show, like, I think a really convenient reason to use this language is the for expansion. One of my favorite parts of this language. I don't even use that much, but when it is useful, it's very useful. So, actually here I would say it's mildly useful, but it's just mildly convenient enough that it's worth it to me. So, for expansion over a component array looks like this. You create a macro called for expansion. The macros in this language are a little bit different. The first thing that you pass in is whatever it is you're iterating over. So the array here in this case would be the component array. And then we want the body of the loop that's going to get passed in. That'll make sense in a moment. Flags are for flags. If you use C++ at all, this is kind of like this language's version of iterators. I think it's much better. You end up writing a lot less code, and I think it's a lot more readable. So this for expansion, it's pretty simple. We can actually iterate forward or backward, but for now, for simplicity, I'm just going to say assert flags equals 0. So it just gets more, like, slightly more complicated when you have to deal with flags. That is, like, does the user want each item to be a pointer, or to be an immutable reference, or immutable copy, or does the user want to iterate backwards over the thing. That's what flags are for. But yeah, that's probably just not making a whole lot of sense right now. So in any case, you just say for, let's say 0 to array.components.count-1, and then it. So you iterate over the components, and you say it is going to be array.components, it's pointer to array.components yeah, need a loop narrator variable here. So so I'm declaring this it in the scope of the other loop. Again, that's just not making. I'll just type it out, and it'll make more sense. It index is going to be I, and then last I want to make the entity ID available. So ID. Let's say entity ID, that's fine, is equal to array.IDs. And then we insert the user's code, insert body. Okay. So this is the whole thing, right? And then if I go back to where the heck was I going to use this? Intelligence. The thing I have sometimes. Okay. So we're going to say for intelligences. Instead of for intelligence components, we're going to say for intelligences. And in this case we have, if I look across over here, these are the variables that have been exposed to me because I'm iterating over a component array, right? I have it index, and entity ID. What I can also say is, I can name them right here if I wanted to. I could be like intelligence I in intelligences instead of it and it index, but I'm not going to do that for just this moment. Say like component I in intelligences. And what that does is it says, okay, I'm iterating over this components array. Instead of using the token it, I want to use the token component. Instead of using token it index, I'm going to use the token I. So I have access to, I'm iterating over all the components, and I have access to the component itself as well as its index. And in here I can just say entity is equal to get entity of entity ID, because over here entity ID has been declared in this scope right here for me by this for expansion, right? So to maybe simplify this a little bit, what you can imagine when you write a for expansion is what happens is at the call site, this just gets pasted into place. Right? Right, so this is my loop looks like now. I'm iterating from 0 to the number of components, -1. It's an inclusive loop. I'm setting a variable named it to be a pointer to one of the components. I'm setting it index to be equal to the iterator variable I. And I'm setting IDs, or entity ID to be equal to the array's ID at I. So again, 2 parallel arrays. One is a component, one is the ID of the entity that owns that component. Then I can use that ID to get the entity, right? And this is what expands every time I use this for expansion. So that's what you have to imagine when you're looking at this, right? And it's just like using iterators in C++. A lot of code gets added when you do an iterator for loop. Here, actually, I think you end up writing usually much less code to get the same thing, and it's really nice. Okay. So I have the entity that owns the component as well as the component itself. When updating the intelligence, I want to get the difference in position. So let's go to globals here. It's called stream AI go to position. Stream AI go to position minus entity position, right? And that's the position difference, I'll say. And toward go to pause, it's just going to be normalize position difference. And then we just want to accelerate in that direction, right? So if you go to physics body, there's a cheap, dumb little function that I added just before this called add acceleration. I call add acceleration to the entities physics body, Zeke. The acceleration is going to be, let's say the distance. Let's say it depends on the distance. So if we're really far away, we want to accelerate quite a lot in that direction, and if we're really close, we want to maybe accelerate only a little. What that's going to do is it's going to look kind of funny. I know what's going to happen because I've been doing this a while. So if you can imagine, what do you think is going to happen whenever I tell this guy, when I click in a place and I tell this guy to move toward that thing, but I'm not just telling him to move toward that thing, I'm telling him to accelerate toward that thing. And I'm not telling him to slow down. Just trying to imagine what's going to happen, and we're gonna see what's going to happen, but I know what's going to happen. Alright, so toward go to distance is going to be length of position difference, and then go to pause, just say this here, is position difference divided by toward to dist. And so if toward go to dist is greater than, let's say 0, we want to accelerate toward it. Okay. So toward go to pause is just call it go to, it's a little less confusing. And then the accel amount, let's say, is clamp let's say I'm going to respace, and let's explain what this does in a second. We're going to respace toward this to, just call it this, right? This. Okay. We're going to respace it from 0, so the minimum distance that we care about reflecting in our logic, to, let's say, 5, the maximum distance we care about reflecting in our logic. So this is the input range, the distances that we care about reflecting, and the output range is going to be the amount we want to accelerate. So if we're close, we want to accelerate 0, right? So 0 distance maps to 0 acceleration. If I'm 5, let's say, meters away, then maybe I want to accelerate 1, I don't know. Actually, not 100% sure what this is going to look like. So I'm going to say toward go to times accel amount, and then delta. Okay. Let's say dist greater than 0.5%. Just to have like a little bit of a, okay, you're inside, you're close enough, let's stop accelerating. Okay. Surely do not define IT, that's maybe, I guess that's for true. It did in fact define IT. Do not bind its iterator variable. Okay. And I just got talking about how great this feature is, and it isn't, let's see. Definitely did define IT index and, oh, it's not an expand. Right. It's a little bit, that error could be better, but it's fine. It's fine. Okay. So if I do this, nothing happens. Is this procedure running? So intelligence, data intelligence B, main, intelligence. It is actually running. Okay. Let's see what that looks like. Did I? Oh, I did. Oops. This is 0, and this is still 0. That's not correct. More debug. Okay. I want to stop on this. Wait until I've moved it. So I've set it right there. Now I want to stop. Update intelligences. Step into that. Alright, position difference is somehow 0 because stream AI go to position is somehow 0. Did I not? Oh, I didn't move it. Oops. Okay. Okay. So now that the AI actually knows where I'm clicking, should be able to get it to move toward it. It's not going to rotate. It's not going to rotate, but it will move. There we go. It's going to accelerate and whoop, shoot right past it, and then accelerate backwards and whoop, shoot right past it. And this is because there is no friction in this world yet. So I'm going to move this over here. And he's gonna find his way toward it. Or he's gonna orbit it. I wonder if he's gonna hit... Wait, he might hit a stable orbit. Hold on. Oh, yeah. Yeah, we've hit stable orbit. Scenario here. Okay, well. That is not satisfactory for this stream, right? So for one, he should probably at least try to orient himself toward that point. And we can do that really cheaply here in the AI update. It should be done in the physics update where everything else is done, but for the purposes of demonstration, we're going to make him rotate here. Okay. So I'm just going to copy some of my old code here. If I can find it. 2 on foot movement. Rotate with input. Max rotation. Sure. Okay. So I'm going to say normalize body velocity XY. That looks good to me. And interpret rotate with time, body next orientation, target orientation, ground rotation speed. We're going to just say the entity dot orientation. I'm not using physics right now. So entity dot orientation is interpret rotate with time. We're rotating from its current orientation to the target orientation with some speed, let's say 3, and the current. There's no physics. Cool, I have a viewer and they are a bot. Well, what's new? Alright. Time. Body velocity XY. Yes, we want entity physics. Velocity XY, that's the physics body. And, linear velocity. I changed a lot of things. Okay. So now, the guy is going to want to rotate toward their movement, hopefully. Well, you would hope so, anyway. But that doesn't seem to be happening. Just gonna crank up the speed here. Obviously, it's not the problem, but what are you gonna do? Alright. So we've got this guy moving toward a position, but not rotating toward it. Looking extra janky. Awesome. Okay. So why are you not orienting correctly? Who knows? Let's see. Let's debug. Okay. No, I don't want to stop on it right now. I'll stop on it after effects. Okay. So I want them to, let's say, go to this point and rotate toward it. I'm not going to. Why not? Target orientation. Has a real value. Entity orientation also has a real value. If we interpret it with time, let's step into this guy. Rotist is pretty big. So the target is this, and the origin is this. That's clearly rotation. Not really sure what the heck's happening here. But so that's weird. If I look at the entity, let's see, entity orientation. I need to see it after the step. So just put a who cares line of code right here, and we're going to no run build, and then run again from the debugger. And he's going to move toward this point. Oh, look at him go. Look at him go. And I want to understand what's happening here. Let's start with here. Don't care about these things. So the target orientation has these values. Z of this, W of this, and the current orientation has just W equals 1. If I update, then it's updated, but... Oh, wait... Is it... Maybe it's interpolating between... Maybe... Oh. Yep. I know what's happening. The physics update's messing everything up. Okay, so... Physics... Update. I have... let's see... Body interpolation. Oh, it's in main. Body interpolation is interpolating from the previous orientation, calculated with physics, to the next orientation, calculated with physics, which is just always exactly what it was the previous frame, because it never changes. So, oh, let's actually run this time. Okay. Alright, so if I get this person moving, hey, look at that, they rotated toward the place they're going, look at that. Oh, that's so nice. And... Oh, there. Oh, yeah, there we go. he likes the speeds are not set at all correctly for the animations. Let me make that slightly less stupid looking. Real quick, graphics here. I just have some baked in speeds for the animations right now. Walk speed is maybe, let's say 0.5. It's maybe 0.2 or something like that. I don't know. 5. Alright. If any of my viewers are not a bot right now, they get to name this guy. and if everybody's a bot, or if everybody's too shy, I think I'm gonna name him. I don't have a name in mind yet, but I'll name him by the end. Actually, you know what? I'll wait until somebody else names him. I had one. Okay, I think I had one real viewer and they left. It's funny. Anyway, okay, so yeah, this guy, he doesn't need a name. If you're on YouTube watching this after the upload, let me know what this guy is called, because I don't know. He's got a shield. He's got a pink shield. The shield is pink because it doesn't have, because the material's set up incorrectly. But it's still pink. So maybe that's a factor for them. Anyway, we have a guy who technically moves toward a point of our choice. Very, very technically. Alright. And what I would like to do... Maybe I could go ahead and put friction in, that way it's not so dumb. I could at least do some semblance of friction. So if I go to physics on this side, I have, NPC has this physics body setup, which just primarily isn't being used, because I was, again, in the middle of kind of a refactor. So, let's see. If body dot user step, null, body.user, call her step with body passed in. That's going to calculate the force speed and the right speed. That allows us to, in our, so basically this is the body template that I created specifically for the NPC, like the physics data basically. It has this as a capsule collider. You can actually see that if let's move this over. This over here. You can see the capsule if we turn on draw colliders. So if I select this guy, select then the just draw colliders here. He's got a capsule. That's his collider. I'm currently using colliders for entity selection, which is not ideal, but it works. And they have a constant mass, and they're pointing friction. So like the friction they have in the direction of their movement is gotten from a function. It's supposed to be a procedure. It's supposed to, basically it's the physics system needs to ask, what is the friction? It can't just get it from constant on the properties. It has to call up a procedure to know what the friction is the idea here. So to reflect that on the physics engine side, we go back to update. Okay. And in this case, we're going to ask, I'm going to ask to evaluate what is friction here. What is friction? And friction is, let's say, multiplied by the acceleration of gravity, which, I don't know, it's pretty hacky little constant right now, but it's fine. So that's what it looks like. That's what getting the 0 to 1 friction constant on this side looks like, the coefficient of friction. I think it's 0 to 1. I might have to brush on. Doing physics, should probably brush up on it a little bit, probably a lot. But anyway, let's see. On the AI or the intelligence side, we're going to. Is it over here? No. On the video game, on the game side of things, where we're creating a physics body template, this procedure, I'm requiring the physics system call every physics step. And this procedure is called anytime it needs to, the engine needs to get the friction, right? Okay. So I want to ask, what is the force speed? Let's say just return clamp body of extra data force speed divided by I don't know, some maximum. Well, let's see. I want to increase. Yeah, it is increasing. So maybe I want to increase as like a square. So like square force speed over some idea of max speed. So let's say just max speed is 2 or something, right? So square max speed. And we're going to clamp that between 0 and 1. And I think this will work. I haven't tried it yet. I just set up this whole system of deriving stuff from procedure calls right before I set it today. So anyway, let's see. Okay. So we got this guy. We just gave him some friction. Now let's give him a place to move. Okay, he's got friction, and friction's maybe not doing anything yet. Okay. Friction. Okay, friction exists, but it's definitely not using anything yet. Okay, so let's say linear velocity. So let's get body dot velocity divided by body dot linear speed. So that's the direction that the guy is moving, is the velocity direction, right? So the friction we're going to apply is velocity delta friction velocity delta. It's going to be negative velocity direction, so the direction opposite the way they're moving. And actually, we probably just want the xy of this, since it's friction. It's not like air resistance or anything. So I'm only interested in really, I'm only interested in how much they're moving along the normal, but right now we're just assuming that the normal, that the ground is always facing up, basically. So you don't have to worry about that. I'm just going to say velocity direction, then we just say velocity direction. It's easier, okay? Cool. So, and then multiply this by friction, and then you can ask, actually we can just first ask if friction, and that should actually be, let's see, friction delta speed is going to be friction times delta, or let's see, physics delta time. And then just having a hard time thinking. Cool. All right. So straight up can't think right now, so I'm gonna stop the stream. It's been fun. I'll try to record a video to make up for this later.